All right, last presentation of the day. My name is Kurt Schuringer. I'm with Amazon Web Services, and quickly about my background is I worked 12 years at Lockheed Martin. We worked a lot on XR solutions, but one of the important things as part of this is the data strategy that comes with some of these utilizations when we talk about XR and future applications. And so as I moved to AWS, that became even more true. Obviously, as a AWS company, we work a lot in data, so that's what we focus on. But now we're able to help with these solutions, and we'll talk a little bit about what this means here in a second, of how this helps scale a lot of these utilizations.
Yeah, and my name is Murphy Ownbey. I work for Koch Industries. We're a large privately owned conglomerate, so we have tons of different businesses across 10 different market segments. And so I work as part of the Spatial Technologies team, emphasizing in digital asset strategy. So working with our different companies to understand the different types of 3D data that they have and how we best utilize it and set up kind of these foundational technologies to achieve like end state utilization. And so we'll dive more into that a little bit later.
Yeah. And before we go a little further, I kind of want to ask the question, can anyone raise their hand as far as have you guys looked at your enterprise data strategy specifically for 3D as you're starting to implement your use cases? Can I see hands if you've looked at that at all? Okay, not very many people actually. Actually, that's very good. So this is definitely the presentation for you. And one of the things that I want to start with in this presentation is the why before we get to kind of the what and how of what these terminologies even mean. The why is very important for this because without knowing why we're doing this, the what and the how becomes a little bit more irrelevant. So we want to start with that piece. And by the end of this, if we have not answered the why for you, please boo us, and then please ask your why question, because we certainly want to get to that first before we even at all get to how we're going to accomplish these things.
Definitely. So yeah, so the why. Why does our team exist? What is the Spatial Technologies team here for? And so really at the end of the day, we're trying to provide the right information in the right context at the right time. So typically we do that with kind of two different strategies, one focusing on from a 2D perspective, and there can be full talks and conferences based on that, and there are, and then from a 3D data perspective as well. So when we dive into the actual main core problems that we're trying to solve with spatial data, if you'll move on to the next. Oh, awesome. The four things that we look at, or the largest ones, are miscommunication, right? We lose millions of dollars at Koch Industry because people aren't able to communicate effectively, right? We're not able to catch problems that we should be able to if we were provided the 3D model, whether that would be in a virtual environment or on a computer screen. So the next would be data silos. So getting people access to the right content so they can make informed decisions. So we talk a lot with our operations teams. So they're not able to have the engineering software licenses or the engineering hardware to pull up 3D content efficiently. And so it creates a high barrier to entry to utilize the data that they could make more informed decisions off of or find information more efficiently. The next thing is technology adaptation, right? There's a lot of vendor lock-in in the 3D space. So people want you to stay inside of their ecosystem, but in a market like 3D data that's consistently evolving, the ability to try out new technologies and stay up to date with the market requires being able to break out of these kind of shielded ecosystems. And lastly would be staffing attrition. So the ability, we see high turnover rates across all industry, as well as loss of that domain knowledge. Our 30-year operators are leaving us, and with that, all the learned experience, and we're having people stay for shorter and shorter periods of time. So the ability that we can give our new operators, our new workers, a more familiar context or get them scaled up more efficiently, and we do that through the use of 3D data because we live in a 3D world. We contextualize things easier when it's presented in a similar environment or similar format.
So the next set of challenges is we're going to put a lens specifically now when we talk about 3D or spatial data. And spatial data is really, again, just anything that surrounds 3D. That could be 2D images that gets stored that may be representative 3D, it could be 2D that gets converted to 3D, it could even just be metadata that surrounds that. So when we talk about spatial data, that's really what we're referring to as part of this. And just like 2D data, when I say 2D data or even let's say 1D data, right, those work instructions that throughout the last 30, 40 years technicians have been using, or marketing teams looking at even just pictures for their sales, or blueprints that are needed on construction sites. Everybody needs those, right? Those are how they get their job done. Really what we're talking about is just making all of that available, but now it's the spatial and the 3D content in the same way. And so what we find today is we have a lot of these PLM systems and MES systems. A lot of them are, and you saw on the previous slide, a little bit data siloed depending on which enterprise you are, especially DoD. DoD has a lot of data silos as part of that. But what's not different is, again, all those people need to be able to access that data, and unfortunately right now, they can't, right? So if you're a manufacturing engineer on the floor, if you need access to a 3D model, a lot of times most corporations today, especially large ones that have legacy processes, they have to go ask a designer, hey, can you give me this? I don't have access to the system, can you go grab me this model? So however long that takes over email to go grab it, and then they get the model. At that point though, right, what do they do with that data? A lot of times now when you have 3D, you have more advanced processes. Part of that is content authoring. Whether you're using different work instruction tools, you have to optimize, you have to convert. And all of that is a very manual process, and it does hinder scale at that point as part of any of that manual. And because now we have more people that need access to this data, we also need to match that with a data strategy of how can we connect to these systems to get that data out in a much more efficient process. Now, another unfortunate thing that we're seeing over the years, and it's kind of with any new technology, is leadership in most companies, including even investors in companies, they look very much at the utilization tools, right? They see the shiny tool that says, hey, this is how we simulate something. This is an XR work instruction. And although that is where a lot of the value sits when it gets applied, what they don't look at is all the infrastructure on the backside for how to get those data to those systems, right? They think of that last. The problem is when you think of that last, they work through, they stand up these systems, they buy these systems, and now they essentially go in this trough of disillusionment because now they don't work right. It doesn't scale right. And the scaling is, right, you've heard it a million times at this conference, is already difficult when you're bringing these new devices or tools to end users, right? There's a whole area there. But now you also running into a scaling problem of, I can't get the data to these devices, right? I can't efficiently get what they need as part of it, and so now you run into a double problem. And so one of the things I would say Koch has done very well, and actually if you've heard the Exxon presentation at the very beginning as well, that they have done very well on, is they flipped the script. They've looked at those utilizations first, but only as kind of a requirement, right? They see what are the requirements for what we need to implement those, but let's actually start on the other side, which is how do we do our data integrations? Where does that data go? What systems do we need to put them in? And that's kind of what we're here today to talk to you about is how do we set you up for a blueprint and kind of also like a reference architecture for getting started on those sides to support all your front utilization cases. And so what that looks like a little bit is two different areas, right? On the right-hand side is where a lot of that sat. It's where your utilization, it's where your work instructions sat, and really even, we start now introducing, we'll talk about spatial data planes, but also generative AI. Generative AI is really just a utilization of a lot of the data on the backside, just like your XR systems are. And that's where your value is. But really, it's two parts. And the left side is what we're going to focus on first before we get back to the right-hand side to start talking about some generative AI. And when I talk generative AI, I'm not talking about just chatbots. A lot of times, a lot of the use cases, right, you type something in, it's aggregating across a bunch of data. Yes, those are useful, but they also are very expensive to implement because they require access to all of your data. So imagine systems, right, where you have a chatbot, you want to ask it even about HR policies. Well, in order for it to know about HR policies, you have to make it available to the model to be able to even query on that data. And getting all that data from all those systems, setting up all those integrations, making sure those systems can even handle the load of all those requests that might be coming in is very expensive. So today, we're actually going to be focusing on some what we call spatial generative AI use cases that actually doesn't require a volume of data. It actually can already work with just even 1 or 2 models and show you the value as part of that to kind of get you started early. But even with that, right, we have to get the data into those models. It's got to come from somewhere. And that starts at the very left side now, which is your collection. Whether you're scanning on a site and making a digital twin, or your end state is your digital twin, but you need your scan data, whether that's going straight into, let's say, a middleware system that we're going to talk about, which is your spatial data plane, or it's coming from your PLM systems, or you're talking about your bill of materials, that's got to come from somewhere. And so part of the spatial data plane concept will be, how do we now make the proper connection to these systems, talk to the right people to set those up as part of that, and now we can efficiently pull that into what we almost deem as like a middleware layer. That middleware layer, if you think of it almost like a data lake now, will then be where all this data will be housed. Now you can do processing on that data. Now the system can be set up so more people can have access. So all your marketing teams, all your engineering teams now have a single place to go. You can still put the proper security controls on it as part of that, and we can talk a little bit about that here in a second. Yep. But that really now allows a centralized place to start scaling, again, everything on the right, which is a lot of times where you see the value for your business.
Yeah, and that brings us to, what exactly is a spatial data plane? So who here has heard of the data lake, or what a data lake is? All right, so it's a large store of data. So a spatial data plane is one step above a data lake. So you have processes, optimizations, transformations in place at that plane perspective to allow you to easily get to your utilization effort, right? So this plane allows you to have more flexibility with that data through those processes that we'll talk about a little later. But it allows you to go into these different segments, right? Or break out of the original format the data was in to get to marketing, to get to, different segments of industry. And so with that, we break it down into a actual different structure, which Kurt will talk about next.
For sure. And so the spatial data plane, I'll say one last thing on this slide is, we want to consider it almost like a foundational IT element, right? This isn't just another tool. This is something that should be just as prevalent and just as focused on as, again, your ERP systems, your PLM systems, things of that nature. If it's not treated as such, it's also not going to be implemented well. So it has to be treated as such in those systems. But the good news also about the spatial data planes, even as being a core system, does rely on smaller IT systems that probably already in place. So it's not like you're reinventing the wheel, you're just adding another layer on top of it and improving your infrastructure to be able to handle these data types.
It's what allows you to have that maintainability and scalability to reach that utilization, right? Yes. It gets you to the end state or to the business value. Without that, right, you're running into versioning issues, you're running into not being able to access or get the data you care about in the right format or at the right time.
And so let's zoom in a little further on what are the components of a spatial data plane. And what we're trying to represent here, like I mentioned earlier, is this is more of a blueprint, right? We're not selling you a single product to say, hey, this is a product called spatial data plane. It's a concept and almost a standard that we're trying to put in the industry as part of even Amazon Web Services to say, regardless if you're hybrid or you work all on site and on-prem, or you just have different providers that are implementing this, the idea is now that we can proliferate this concept to help strategy-wise enhance the industry so you can scale those solutions. And so really there's 3 main parts to this, right? We talked a little bit about where this data comes from, whether you're uploading it direct or it's coming from a lot of source of truth systems. The core and meat, though, kind of sit in the middle, right? So as part of that, you have your core storage of that data, whether you're replicating that data into that data lake and just storing that. But it's more so than just the storage of that data, it's also then the access of that data, right? So there might be a web front end as part of that, and you'll see a little demo picture at the end where Koch developed a system called Koch 3D that allows users now to log in just to even be able to find the parts that they're looking for. I mean, back when I was at Lockheed, I can't tell you how many times it was just such a problem to even find the right parts that you want to work with, the right CAD, the right revisions. Am I working with the right data? Am I asking for the right data? And a lot of times when they get it, they're like, crap, This is not the model I was looking for. And so now this also provides a system that they can go into, have a web platform as part of, and just even find the data before they even push it anywhere downstream.
As well as having the ability to access that data more efficiently, right? So I don't need a software, I don't need to download something, I don't need to talk to IT or get the correct permissions, right? When you come from a web-based platform, you're sending a link, you're doing some role-based access, or you're gaining access, via the platform. And so in terms of getting access to your data more efficiently, or more effectively, that barrier is essentially eliminated.
And so now once we have this data right in this data plane of storage, now the next thing is your metadata, the indexing of all the things that relate to it. Right now you have your CAD, now you need a bill of materials that relate to it. There might be serialization data that goes to it if you're in a manufacturing. All of those things can be represented whether through metadata. Koch implemented actually a knowledge graph system that is very efficient as far as indexing all that around that data. And there's many different expansion layers that you can put on that. And now once you have essentially this knowledge graph of all your data, now you can really start to work with it, right? Not just from an access perspective, but from a processing perspective, right? There's a lot of times that we have to still convert from a CAD to a mesh file, or you have point clouds. You might have to do decimations and optimizations on it. Those are all processes now that you have a centralized place that makes it easy to get to that data, to now kick off processes behind the scenes to automate the generation of those. Meaning now, when something gets updated in your PLM system, it can, let's say, sync down to this data lake structure and automatically start kicking off all the processes to do the conversions that are needed, again, now for when we're getting to your downstream consumptions.
Yeah, again, it focuses on the idea of being agnostic. We preach having agnostic 3D data as being essential moving forward, again, to eliminate those barriers to entry, right? Eliminating the vendor lock-in, the cyclical environments that this 3D data sits in. So having those processes in place to where I can have, set standards of open standards of 3D format that I can easily leverage across these new technologies is what allows us to, be efficient or run proof of concepts more effectively, because we don't have to wait for our vendors to approve or export the format that we care about.
And so the last piece of the middle, and I'll speed up a little just for the sake of time, but we've got asked actually a couple days ago, or over the last few days when we've been talking about these concepts, right? People talk about the distribution layer. That is very much part of this as well. People ask, how does this relate to streaming of that data? That is all actually part of the spatial data plane, but those are some of the more outer layers, right? The more important piece is, how do we get the data, how do we store it, and how do we process it? But now we do start looking at what are the layers that we start adding onto this, so now we can distribute it, whether it's still a file download or a pixel stream, or even now there's other streamings like 3D tiles. And so those are all now methods to start going towards the very right side, which is all the egress of data. Those are all your utilizations. Now, one of the utilizations we're going to hit on today is the generative AI, and that's this very next topic now. But you need to set all this up, because without setting this up, you're going to be dead in the water. We've seen so many cases, even at Amazon, where customers ask for generative AI implementations, but they don't have their data set up correctly. Their data strategy is not there, so they're not able to get the data in these systems to be able to work on that.
Another example is digital twins. So if you're implementing a facility digital twin and you don't have a way to you streamline your MOC process and update that digital twin, as soon as your first change management happens at the facility, right, the twin is pretty much useless. And so having the ability to efficiently update that 3D side so that you can have an evergreen digital twin, this is where the spatial data plane comes in to automate most of that process for you.
And so with that, we're going to leave this for a second. We'll come back and revisit a little bit the spatial data plane concept as it starts building to the generative AI. But now we're going to introduce a little bit on the spatial generative AI and what we mean for that compared to, let's say, like I mentioned, the chatbots.
Yeah, and we really break it down into kind of 3 different segments that we're seeing with spatial data and Gen AI. So the first one's going to be analysis, being able to recognize exactly what is in a 3D scene, right? So an example would be pulling, metadata over what am I looking at, what is in here, as well as, being able to label effectively. The next one would be manipulation. So now that I understand what's in my scene, how am I able to break this content out? An example being if I have a facility scan and I want to start or understand, where does this pipe run? Well, from an analysis perspective, I need to understand that, oh, this is a pipe and this is where it runs. And then from an end user perspective, if I want to manipulate that, being able to select that pipe and be able to track it throughout my full facility. And so then lastly would be generation, right? Creating something from nothing. So the ability to use like natural language to generate 3D content or other types of generation techniques to more efficiently build out 3D renders, full-scale scenes, stuff like that.
And we do have a slide coming up that does show a little bit more of the use cases, but the one actually you see right now on there is one that we did with a telecommunications company, where they were doing drone aerial footage essentially of the towers because they had to make sure that the configurations were right, the antennas were in the right locations. There are other companies that actually go up on those towers because they don't just usually belong to one telecommunications company. And so they need to make sure that other companies aren't accidentally adjusting their antennas, moving them, et cetera. So in this case, we actually used AI to not only recognize what those antennas were, but then additionally, so that's the analysis piece, goes in the manipulation of how do we segment out just those antennas so we can do further calculations on everything from angle to height from the ground, those sorts of things. And we'll cover those a little bit more when we get to our use case slide. And so this is just another representation of that first slide, now kind of piecing a little bit of everything together. Right? We showed the full picture of generally what a spatial data plane, and now we have a system. So AWS has an open source solution called the Visual Asset Management System. Really, it's just a system to get customers going, just so they can get their feet wet with what does a system like this look like. And actually, Koch 3D took this system, and you'll see it at the end, and actually built their own version out of it. But there's actually plenty of software vendors that we're working with here on the floor that have production-grade systems that we certainly recommend to use as part of that. And so again, the idea here is we're not pitching a product, we're pitching an idea that you can implement, and you can go to any number of these vendors, and now you have a better idea of what you need and know what to look for as part of that. And so you have the visual asset management system that we work with here, and you'll see the different components from authentication, there's the website component, there's a storage, and then you'll see again that process layer. And really all that process layer is how do you kick off pipelines where you can now orchestrate whether you're training an AI model, whether you're doing a 3D optimization pipeline with whichever tools, right, that you may pick that may be down on the expo floor from the vendors that you like. Really, you just need to be able to orchestrate those and have a place, again, that you can work through that data as part of that. And you'll see, like, I mentioned generative AI, but really those pipelines and jobs, they can be anything that you want. Really, it's just a process that takes the data, works on it, and kind of delivers it back to this pipeline, and also takes care of all the revisioning and versioning as part of that process. And so this is getting now into, what's the use cases for this data strategy, specifically even when we talk now generative AI, right? We talked about analysis a little bit, but analysis is a lot of things. It could be looking at the scene, recognizing those parts, looking at the IoT data that might be going in and correlating that back to the scene. And again, you don't need a lot of data with the ones that we've at least listed to get started. In fact, we tried to actually put up use cases where you don't have to do all your data integrations to those systems because we realize they do take time, right? There's no silver bullet to this in that case. But at least even if you have a single file, how can you at least implement some models that get you to this? And so analysis is where everything starts because most of the time you're dealing with existing data that you need to be able to interpret. Then after that point, right, we talked about segmentation. This is the manipulation layer, whether you're segmenting models out, or you might even be able to optimize them at some point. There might even be cases that you've seen here, right, where somebody talked about, hey, we want to talk to a generative AI model to create a new object, right? In my scene, generate a globe or generate something else. Those are also all possible today. And all of these things that we listed there's models out there from generative AI to be able to make this happen. For example, Meta for manipulation has a segment anything, it's called the SAM model, that today you can actually use even on 3D data through certain techniques to still get all your segmentation that you want. And so an example on the top that you see is actually a digital twin model that came from a data lake, was re-represented from 2D images to 3D as part of 3D reconstruction. IoT data was layered on top of that, and now actually even in there, you have a chatbot as part of even just that data that's available that you can now start asking questions about the scene. So this was actually used for a construction company to see how well that their building operations were working, and that was a use case that we did a prototype for actually at Amazon as part of that. And the last one being generation. Generation is actually the most tricky and the hardest one. The ones that we see today that are the most useful use cases are with synthetic data generation, actually to retrain models for analysis again. So you can do synthetic data generation to essentially put different backgrounds on your CAD, to essentially train a model now to specifically look for your parts on a manufacturing floor, or train if I need to look for hard hats in the field, right? Like things that potentially maybe a model may not be trained on, but it needs a bunch of different data points to be able to still train. And so those are some of the use cases that we've seen. Gaussian splatting, which is a way actually to generate 3D data from 2D, it's a 3D reconstruction method, is actually a generative AI model, and that's that Long Beach example where you can see a few pictures, and then you'll see also how that translates over to a 3D model as part of that. But that really is just a Gen AI model, and that does fall under kind of the generation aspect of that.
And looking long term, some of the things that Koch we're trying to look at is 3D reconstruction, especially from 2D drawings, right? So a lot of our 2D drawings, they date back 50 plus years. There's no 3D CAD that's associated with it. So, but if we're building out large-scale digital twins, stuff like that, leveraging generative AI to generate, be able to read, understand these 3D drawings and generate, roughly and then eventually fully accurate representations or CAD drawings to bring us to a more digital presence for all of our facilities, not just new capital projects or new things after, our MOC processes. So where Koch is currently using generative AI is in metadata generation. So we have Koch 3D, like Curtis talked about. What that allows us to do is we can process and store 100 different file formats of 3D data, from LiDAR scans, XR models, engineering, CAD, all in a single source of truth, also integrate into PLMs, et cetera. What we're doing with our AI pipeline is it allows us to generate keywords and metadata around an asset. So for instance, you're seeing a picture of a pump, and so our pipeline produced industrial pump machinery, stuff like that. So immediately what that allows for is semantic searching. So now instead of needing to know the exact ID or the name of the 3D model, I can search for keywords across my entire library of 3D content. But looking long term, where this is really effective is when we start to train large-scale generative AI models on our 3D content. We now have more robust metadata to train our models on our specific content. So if I'm trying to search across, one day search across about a certain part or a certain piece of equipment, I now have a more accurate model because I'm feeding it additional data to train on.
Yeah, so this is definitely a feedback loop in, and that's one of the big things that we see with generative AI, and again, having some place like a spatial data plane to feed that back into, revision that, et cetera.
So now we'll jump back into some of our takeaways. So for those who are going to look at developing this digital asset strategy, what do I recommend to start thinking about? These are the things I talk to our different companies, these are the most important things. So from a collection standpoint, it's understanding your existing spatial data. So not only what 3D data lies inside your current organization and where it sits, but also what is available to you. So we have worked with our procurement teams to understand, are we getting all the vendor CAD that's available to us? Because typically we just don't ask for it. We have models that we could use in virtual reality trainings and things like that we never get because we had no place to store it, we had no use for it. So the next thing would be centralizing and controlling your data from a storage and management perspective. So understanding what type of access controls or what type of access patterns people need to be able to access the data, right? You don't want everyone to be able to delete your important 3D models. So understanding, we recommend role-based access, where you have an admin, editors, viewers, et cetera, and also coming from, again, a centralized source of truth. So whether that's being fed in through your PLM them and then automatically updated to your data plane, or whether the data actually sits in the data lake or the spatial data plane. And lastly, and most importantly, is understand the problem being solved when you reach those utilizations. I see too many people across our company applying technology for the sake of technology. You want to apply 3D data because it's cool, or you think it's going to be important, but you don't really understand what's the actual business value that I'm getting out of applying the spatial data, right? Whether it's being time saving, whether it's learning faster. So understand exactly what is the most important thing, or what's actually being solved here by leveraging this new technology. Not just applying the new technology because I saw it at a conference and I think it's going to solve problems. Like, really understand what are the core business problems that I'm solving before you go forward and implement a spatial data plane or a utilization, an end state utilization.
And I guess I'll end this with, today we didn't cover a lot of the how. We realize that goes deep in the weeds, but hopefully we showed you something that allows you to ask more questions,
Yes.
right? It allows you to know, hey, there's this whole area that I might be missing, right? Ask the why questions. We showed you a little bit of the what and what you can do with it. We showed you a little bit of the how as far as very top level diagrams, but you don't know what you don't know until you hear it. And so today was really to educate you on this is what you may be missing as part of your business, and now you can go, and whether you ask us, other people, the vendors downstairs, you can start asking questions a little bit more smartly about what you need. And so that's really why we're here, is to show you that blueprint, to give you those ideas, to now go forth and see what you're missing.
Yeah. Thank you, guys.
Any questions before we wrap up? Anybody? Yes. Way back.
Yeah, Ron Thompson, interesting stuff. How do you explain this to a business executive to get support and funding?
Yeah, so that's a tough one, right? But and it's obviously the most important because it can't move forward if you don't have your executives backing you. One of the first things that I look at, or that helped me, was understanding that we're only generating more 3D content. It's not getting smaller, and so we first showed these kind of one-off proof of concepts, right? We've built a virtual reality training. It saved millions of dollars. But then we talked towards all the problems about scaling that across the organization and talking about what are the foundational technologies that are required to make this one training that was really successful, or this one utilization that was really successful across the whole business. And so that's where spatial data plane comes in, right? And that's how we've been able to connect our executives or high-level leadership. It's a core and foundational technology that allows you to scale these important value-creating, experiences. So it's really connecting with the scalability and maintainability aspect for like long-term value creation.
And one light bulb moment actually we had with a customer, this was actually several weeks ago, was we did a workshop with them, and they wanted to specifically see a product that was an end utilization product. It was a simulation product that they wanted for digital twin. They wanted to see how to basically improve their manufacturing line. What we did was we kind of worked backwards. We said, okay, we're going to show it to you. The VPs were in there. We only had maybe, I think, 15, 30 minutes. But then we started quickly asking the questions of, where are you getting this data from, right? What do you have? And they're like, well, we don't have any 3D scans, okay? Well, that's, how you can't simulate something where you don't start with anything, so we need to first start there. And I said, okay, well, where are you going to put that data? Well, they mentioned a few systems, like, okay, well, are those systems geared to pull out, right? And you kind of walk them through the process, and it doesn't take very long to make the light bulb moment come on. It's like, oh, right, I can't just buy this tool and do this simulation. I need all these steps in between. And quickly getting to that light bulb moment by kind of working backwards as far as like what you need does help that process quite a bit. Doesn't always work, and sometimes you don't get all their attention for even a workshop for 15, 30 minutes, but if you can, that's one thing that we saw a couple weeks ago that actually worked quite well to kind of get to that realization.
Yeah, that's what's been most effective, is the work backwards model for sure.
All right. Thank you, gentlemen. Appreciate it.
Thank you. Thank you. Awesome.
All right, so as we wrap up, I have good news, and so the good news first is we're done.